In this video, we're going to talk about MAT0028, Module 6. We're going to talk about multiplication and division of rational expressions. Again, I want you to realize that this is not new rules. Y'all have done multiplication and division of fractions. So what I've just highlighted are not new ideas. The key difference between dealing with just basic fractions and dealing with rational expressions is you need to remember that a lot of times we use shortcuts. When we divide something by, if we have 2 over 10 and we rewrite it as 1 over 5, you actually are factoring something out. You're simplifying by canceling like factors. So this is the piece I want to keep reminding yourself. If it is multiplication, we can cancel like factors, but they must be factors. So if it's multiplication, I want you to factor every piece. Which what I mean by piece is every numerator, every denominator. Then you look for like factors to cancel. So going to number 4. Again, though, please make sure you're clear on the test. If you're multiplying or adding, it will say it in the directions or have a symbol. If nothing factors, please get in the habit of going ahead and writing parentheses. So what I mean by that is x minus 3, can't do anything there, but I'm going to put it in parentheses so my brain knows I can't cancel that unless it exactly matches. Denominator of the first fraction, and please pause this at any time that you need to. You can rewind it as well. Factors to x and x. Signs will have to be opposite. Two numbers that multiply to give me 15 that are opposite signs, that when I add them together, I will get a positive 2. So that should be a positive 5 and a negative 3. Double check your signs before you go any further. They will like to give you a lot of difference of squares because, again, that should also be a pretty straightforward factoring problem. Binomial, there's no GCF, so it's a difference of squares. So we should have an x plus 5 and x minus 5. Finally, my denominator, again, leading coefficient's a 1, so it's going to be an x and an x. Since a minus 40, it's going to be a plus and a minus. Multiplies give me negative 40, that when I add them together, I get a positive 3. That should be a positive 8 and a negative 5. Double check, because notice I could cancel with a plus 5 or a minus 5, so just because it's there doesn't mean it's correct. Double check your signs. So now I'm going to cancel any like factors, and I want you to realize now that it's multiplication, everything needs to be factored first. I can cancel any like factors that are where I have 1 in the numerator and 1 in the denominator. So a lot of people make the mistake and think they have to be like a cross. They don't. They can be anything numerator and denominator. So this x minus 3 cancels with this x minus 3. This x plus 5 cancels with this x plus 5. This x minus 5 cancels with this x minus 5. The mistake people make on this problem is do everything right and then the last step they do wrong. So please use your space wisely and scan it. What's left over in the numerator? So literally take your pencil and go from left to right. If there's nothing, you always have a 1 left. Same thing in the denominator. There's an x plus 8 left in the denominator. If it's helpful, you can leave those parentheses there. But if you put x plus 8 instead of 1 over x plus 8, it's different. It's the same idea as if I have a half or if I have the number 2. Very different numbers. So please be careful. Make sure you're bringing across that numerator and denominator piece. So we're going to look at number 5. Number 5 is a division problem. So the first thing we do need to do is rewrite it as a multiplication problem. Some of you will do more than one step at this first step. I'm going to try to just do one step at a time to show. And as I'm talking, I do need to flip that. So it becomes 11k over 2 minus k. Now it's multiplication. Now I factor every piece and cancel like factors. So in the numerator here, that is a difference of squares. K minus 2, K plus 2. Nothing to factor for the 3k squared. Now, if you like to rewrite it as 3k times k, you can do that. In this denominator piece, remember we don't want it in that order. So I rewrite it, negative k plus 2, and then I'm going to pull out the negative, which changes both signs. So I end up with negative 1 times k minus 2. I don't go directly there. I always show that middle step first. Now it's completely factored. We're going to cancel any like factors. So the k minus 2's cancel. The key people tend to forget is looking at the monomials. So notice there's a difference here. There's no plus involved with these. So it's the same idea as if I had an x over x squared, they would cancel. So one of the k's cancel, but be careful, there is 1k left in the denominator. So in the numerator, I'm going to scan across. I have 11 times k plus 2. I do not need to multiply that out. We always put the monomial first, and the k plus 2 is my binomial. We're going to write it second. So for my denominator, I have 3k times a negative 1, which would give me a negative 3k. Double check, look at it. Can I simplify anything else? No. Could you write that as 11k plus 22? Yes. But when we're factoring with multiplication, we generally leave it in factored form. Again, pause it at any time you need to and rewind. So on number 6, it's a division problem. So our first step should be rewriting it as a multiplication problem. You have to do that first so that you don't fall into the trap of canceling things that aren't supposed to cancel. Now we're going to cancel anything we can. Now, notice again, I'm going to go ahead and put the parentheses around those numerators because there's nothing I can do to those. So I have an x plus 1. Now, the denominator. This one's a little bit trickier because it's not a leading coefficient of a 1. It's okay if you need to do it over on the side. If you want to use the AC method, you can do that as well. So I'm just going to do that down here below, just as a reminder. 2 times 3 is 6. The signs would both be positive. So this would be 2 times 3. That gives me 2x plus 3x. Factor by grouping. I can pull out a 2x. That gives me an x plus 1. Always bring your sign down. Out of the second pair, I can pull out a 3, which leaves me with an x plus 1. Parentheses have to match. So that's the x plus 1. What's left over goes into the other parentheses. So you totally can do this problem. You can totally do this problem with my AC method, which is what I did here. Or, again, I could have looked at this one and said, this has to be 2x and x because it's prime. And 3 is also prime, so I really only have one choice of the numbers. Now, I would have to choose between doing 3 and 1 in which location, but you would only have 2 trials at most to try for that piece. Something that could have also kind of led you to that guess and check is notice the x plus 1 on the top. It's not a guarantee, like I keep saying, but usually something's going to match. So if it matches, it's going to help you out. So numerator, nothing to factor for that second rational expression. Out of the denominator, I can pull out a 20, and that leaves me with an x plus 5. So again, all I do is pull out my GCF. Now I factor anything that can factor and cancel. So the 2x plus 3's cancel. The x plus 1 cancels. So my answer here should be 1 over 20 times x plus 5. Again, make sure you're bringing across the division bar what's left over.